Hello student, good morning. I am Dr. K.Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing question, answer and explanation based on states of matter, and I have discussed many questions based on Boyle's law, Charles' law and absolute scale of temperature, and also I have discussed questions based on ideal gas equation. Now I will continue questions, answer and explanation, that is based on calculation of partial pressures including Dalton's law of partial pressure, Graham's law of diffusion and kinetic molecular theory of gases and deviation from ideal behavior. Now just question number 29 I am reading. I have finished up to question number 28. Keep pen paper with you. Aqueous tension of water depends upon first the amount of the water taken, second the temperature only, third both on the amount of water and temperature, fourth neither the temperature nor the amount of water but on certain other factors. Again I am reading one more time question. Aqueous tension of water. What is actually aqueous tension? Then pressure exerted by the water vapor, that is called aqueous tension. Then question is aqueous, actually it is mentioned in question what is the aqueous tension. Then aqueous tension of water depends upon first option the amount of the water taken, second the temperature only, third both on the amount of water and temperature, and fourth neither the temperature nor the amount of water but on certain other factors. Just you think, you can answer it easily. Okay, after that I will give answer and explanation. At least you think. Its a correct answer is option B, that is the temperature only. This correct option is temperature only. Why? Then now I am telling you. Actually aqueous tension of water depends only on temperature. If temperature is less, then water vapor will be less. If temperature is more, then water vapor will be more. And so it depends, aqueous tension depends only on temperature. Amount maybe it will not depend upon amount. Whatever will be the amount of water, that does not matter. But temperature matters. In summer water vaporize more, and whatever be this quantity, that how much water will vaporize, that depends upon what was the temperature. Correct? Then even for a small pond or a big river, that will evaporate, water will evaporate. How much it will evaporate, that depends upon temperature. Okay, if less water is there, then that also it will evaporate. And if more water is there, then also it will evaporate. Hence temperature is, you can say, main things important. Now next question I am discussing. A cylinder is filled with a gaseous mixture containing equal masses of CO and N2, means carbon monoxide and nitrogen. The partial pressure ratio is, first option, partial pressure of nitrogen is equal to partial pressure of CO. Second option, partial pressure of CO is equal to 0.875 N2. Third, vapor pressure of CO is equal to 2 PN2, means vapor pressure of nitrogen, double of vapor pressure of N2, 2 PN2. And fourth, vapor pressure of CO, that is equal to half PN2, means pressure of nitrogen. Again question I am reading. P means pressure here. A cylinder is filled with a gaseous mixture containing equal masses of CO and N2. The partial pressure ratio is first option PN2, that is equal to PCO, means partial pressure of nitrogen is equal to partial pressure of CO. Second, PCO is equal to 0.8875 PN2. N2 means nitrogen gas. Third, PCO is equal to 2 PN2, means double the pressure of nitrogen. Fourth, PCO is equal to half pressure of N2. Just to think what will be the correct answer. After that I will tell the answer and explanation. Just to think. Its correct answer is partial pressure of nitrogen is equal to partial pressure of carbon monoxide. This is actually correct option A. How? Now I am telling you. Carbon monoxide, that is equal to N2, that is equal to weight. What is the given in question? What they are told about the gas quantity, then quantity is taken how much? Mixture containing equal masses, both have equal masses, mixture containing equal masses of carbon monoxide and nitrogen. Then both mass is equal, mass of carbon monoxide is equal to mass of nitrogen, that you can consider as a W gram. Then here number of moles you can calculate, number of moles. Then for carbon monoxide, its a weight, just weight is not given, only equal mass is given. Then both weight are equal. Then we consider W. Then W divided by 28. Because carbon and oxygen, what is molecular mass? 12 plus 16, 28. Correct? Then for that you consider as a N1, number of moles of CO, that is equal to W upon 28. And for nitrogen, how much? The nitrogen molecular mass is again same, 14 into 2, N2, 2 into 14, 28, same mass. Then its number of moles will be again same, W divided by 28. Then both have same mass. Then obviously number of moles are equal, hence it will create equal partial pressure. Correct? Partial pressure due to carbon monoxide and due to nitrogen is equal. Hence, option A is correct. Now, next question. 31. The ratio of partial pressure of a gaseous component to the total vapor pressure of the mixture is equal to, first option, mass of the component, second, mole fraction of the component, third, mass percentage of component, and fourth, molecular mass of the component. Again, I am reading the question. The ratio of partial pressure of a gaseous component to the total vapor pressure of the mixture is equal to, first option, mass of the component, second, mole fraction of the component, third, mass percentage of the component, fourth, molecular mass of the component. Just to think in a correct way, you can answer very quickly. Just to think. After that, I will tell the answer and explanation. Its correct answer is mole fraction of the component. Mole fraction of the component. You know the, you can say, formula. Partial pressure of a gaseous component in a mixture is equal to mole fraction of the component into pressure of the mixture. Mole fraction means suppose gas A is there. The gas A, what is the pressure divided by total pressure? That is called mole fraction into total pressure. Upside total pressure. Then pressure due to gas A divided by total pressure. That is this thing's partial pressure of gas A. Partial pressure of the gas A divided by, suppose two gases are there. Then now you can tell that is the out of total means A divided by total number of molecules. Total number of molecules means suppose it was first gas was, you want to know to calculate for gas A, then TA divided by PA plus PB plus PC plus PD, like that way, into, that is actually, if you consider both, then it is called fraction. Out of total, what is the, you can say, pressure of any particular gas. That is the partial pressure of that particular gas divided by total gas into pressure of the mixture. What is the total pressure of the mixture? Correct? Then now correct answer is that is the mole fraction of the component. Correct? Suppose there was two gas, then M1 plus M2, then M1 divided by M1 plus M2. Suppose you have mole, first gas has M1 mole, other gas has M2 mole, then M1 divided by M1 plus M2 into total pressure. Correct? Mole, that is also you can tell more number of moles of individual gas divided by total number of molecules, total number of moles into total pressure. Hence, option B is correct. Mole fraction of the component. Now this I told you now the ratio of partial pressure of a gaseous component of the total vapor pressure of the mixture is equal to mole fraction of the component. Now next question I am telling you, that is based on Graham's law of diffusion. The rate of diffusion of a gas is proportional to, 4 options are there. First option, P upon under root D. Second, P upon D. Third, under root P upon D. Fourth, under root P divided by D. Again one more time I am reading the question. The rate of diffusion of a gas is proportional to, first option, P upon under root D. Second, P upon D. Third, under root P upon D. Both P and D are under root. And fourth, under root P divided by D. Just to think, this question I think you can answer very soon, very quickly. It is easy means direct answer is there. Direct answer. According to the definition, only definition of diffusion, rate of diffusion. Just to think. Its correct answer is P upon under root D. P upon under root D. Correct? This is actually correct answer. Why it is correct? Then I told you direct, that is a definition is there. Rate of diffusion is directly proportional to 1 upon under root D. Correct? And also you can tell directly proportional to P. Rate of diffusion is proportional to, it is proportional to two things. First, you can say 1 upon under root D. Correct? And second, it is directly proportional to P. Rate of diffusion depends upon two factors, density and pressure. Then on density, how both are related, then rate of diffusion is proportional to 1 upon under root D, and second, directly proportional to P. Hence, if you will consider both, then rate of diffusion will be P upon under root D. Means directly proportional to P and inversely proportional to under root D. Hence, correct option will be A, P upon under root D. Actually, all questions are important and can be asked in examination also. Now, next question I am reading. Question number 33. That is based on kinetic molecular theory of gases and deviation from ideal behavior. Now, I am reading the question. Which one of the following represents the kinetic gas equation? Correct? It is also easy, provided you should remember the relation. First option is given, PV is equal to nRT. Second, P plus A upon B square in bracket into V minus B in bracket, that is equal to RT. Third, PV is equal to 1 upon 3 MnC square. And fourth, R1 upon R2 is equal to under root M2 upon M1. Again I am reading one more time. Which one of the following represents the kinetic gas equation? First option is PV is equal to nRT. Second, P plus A upon B square in bracket into in bracket other bracket V minus B, that is equal to RT. Third, PV is equal to 1 upon 3 Mn C square, or U also you can tell, 1 upon 3 Mn U square. Velocity you can represent either in U or C. And fourth option is R1 upon R2, that is equal to under root M2 upon M1. Quickly you can answer this directly, that is a direct relation is there. Okay, just to think. Its correct answer is PV is equal to 1 upon 3 Mn C square or U square, whatever you can tell. PV is equal to 1 upon 3 Mn U square. This derivation is there in the chapter. Okay, in the gaseous state already I have discussed. Then PV is equal to 1 upon 3 Mn U square, where U is the velocity. And correct option is C. Option C is correct answer. Now next question I am reading. If most probable velocity is represented by alpha and fraction possessing it by f, small f, then with increase in temperature, which one of the following is correct? Again I am reading, then option I will tell you. If most probable velocity is represented by alpha and fraction possessing it by f, f means fraction, small f, then with increase in temperature, which one of the following is correct? First option, alpha increases, f decreases. F is fraction, you remember, a small f is the fraction. And second option, first option is alpha increases, f decreases. Second option, alpha decreases, f increases. Third option, both alpha and f decreases. And next, last option, both alpha and f increases. Just you think what will be the correct. Again, option I am telling you. I am reading complete question one more time. If most probable velocity is represented by alpha and fraction possessing it by f, then the increase in temperature, which one of the following is correct? First option, alpha increases, f decreases. Second, alpha decreases, f increases. Third option, both alpha and f decreases. And fourth option, both alpha and f increases. Just to think. You have to think for this question. Only then you can answer correctly. Its correct answer is alpha increases, f decreases. Means option A. Here alpha, I told you, it is the most probable velocity, and fraction possessing it is f, correct? Then f decreases and alpha means most probable velocity increases. Okay, this what is actually other explanation I am telling you. With increase in temperature, most probable velocity increases, you remember. In general way also, if temperature increases, velocity increases in a general way. Then with increase in temperature, most probable velocity increases, but the fraction possessing this velocity decreases. Correct? If you talk with the fraction, then with increase in temperature, most probable velocity increases. That is correct. But the fraction possessing this velocity decreases. With increase in temperature, fraction that will decrease. Okay. Now next question means first option is correct. Now next question I am reading. According to kinetic theory of gases, the root mean square velocity is directly proportional to first option T, second option T square, third option under root T, fourth 1 upon T. Again I am reading the question. According to kinetic theory of gases, the root mean square velocity is directly proportional to first option T, T means temperature, second T square, third under root T, fourth 1 upon T. Just to think, this also you can answer if you are knowing the subject matter. Just to think. Its correct option is, answer is actually direct answer. Under root T, correct? And relation is there, you know, that U is equal to under root 3 RT upon M, correct? Under root 3 RT upon M. Then you can write directly T is under the square root. Hence you can write individually, also you can write separately. U is equal to directly proportional to under root T. Because under root 3 RT upon M is there. All are under root. Then individually also you can write that under root T. And or also you can write U is equal to under root 1 upon M. Like that way, separate you can write. Then here U is equal to directly proportional to under root T. And say option C is correct. Now next question I am telling you. Next question. That is the question number 36. Question number 36. Which one of the following relationship is correct? First option, PV is equal to 3 by 2 kT. Here K is small k, Boltzmann constant. Second option, kinetic energy is equal to 2 by 3 kT. Third option, Z, capital Z. Z is equal to nRT upon PV. Z is equal to compressibility factor, remember. And fourth, PV upon T is equal to 2 upon 3 K. Again I am reading one more time question. Which one of the following relationship is correct? First, PV is equal to 3 by 2 kT. Here K is equal to Boltzmann constant. Okay, it is not given in question, I am telling you. Then PV is equal to 3 upon T, 3 upon 2 kT. Second option, kinetic energy is equal to 2 upon 3 kT. First option was PV is equal to 3 by 2 kT. And second, kinetic energy is equal to 2 by 3 kT. Third is equal to Z is equal to nRT upon PV. nRT upon PV. And fourth option is PV upon T is equal to 2 by 3 K. Just to think. Just say this is a direct relation. If you are remembering the relation directly, you can answer. Okay. Just to think. Correct relationship you have to tell. Its correct answer is PV upon T is equal to 2 by 3 K. PV upon T is equal to 2 upon 3 K. Option D, last option. How? Now I am telling you. Here you know that PV is equal to 13 mn C square. That you know. Then this, if you will multiply it by 2 by 2, then same things you can write. PV is equal to 2 by 3 into half MUA. M into N means capital M. Capital M, molecular mass you can write. Then you can write 1 by 3 mn U square or C square, whatever we. They are just to multiply by 2 into 2. Then you can write 2 by 3 into half mu square. Then half mu square means kinetic energy. Means 2 by 3 into kinetic energy. Means PV is equal to 2 by 3 kinetic energy. But kinetic energy is directly proportional to T. Hence in the place of kinetic energy you can write T. Hence you will get PV is equal to 2 by 3 KT. You will get PV is equal to 2 by 3 KT. Then PV upon T is equal to, you will get 2 by 3 K. 2 by 3 K. It is a very good question. Again I am telling you, PV is equal to 1 by 3 mn U square. Then mn means molecular mass. Then you can write same way 1 by 3 mu square. But just to multiply by 2 by 2, it will not affect anything. Then you can write now 2 by 3 into half mu square. Half mu square means kinetic energy. Then now you got 2 by 3 kinetic energy. But kinetic energy is directly proportional to temperature. Hence PV is equal to, you can write 2 upon 3 KT. Or you can write P, just after cross multiplication, same thing you can write PV upon T. Actually in the place of kinetic energy you can write KT. Then now PV is equal to 2 by 3 KT. Then what is the value of 2 by 3 K? Then PV upon T. T you bring divided by PV is equal to 2 by 3 KT. Then 2 by 3 K is equal to what? Just to divide by T. Then PV upon T is equal to 2 by 3 K. And last option is correct. Here K is equal to Boltzmann constant. That is for R value for one molecule. One atom you can tell, or one molecule. Correct? Divided by Avogadro number. Divided by R divided by Avogadro number. That is called Boltzmann constant. Correct? That is for 1. Then that's why here correct answer is D. Correct answer is D. PV upon T is equal to 2 by 3 K. One more question I want to discuss today. I am reading question number 37. Which one of the following is not a correct postulate of kinetic theory of gases. First option, the molecules of gas are not directly continuously moving in different direction with different velocities. Second, the average kinetic energy of the gas molecule is directly proportional to the absolute temperature of the gas. Third, the volume of the gas is due to the large number of molecules present in it. And fourth, the pressure of the gas is due to heating of the molecules on the walls of the container. Then you have to tell correct postulates of kinetic theory of gases. One more time I am telling you. The molecules of a gas are continuously moving in different direction with different velocities. You have to tell correct postulates, remember. Now second option is the average kinetic energy of the gas molecule is directly proportional to the absolute temperature of the gas. Third, volume of the gas is due to the large number of molecules present in it. Fourth, the pressure of the gas is due to the heating of the molecules on the walls of the container. Just to think, it is full of concept. Okay, just to think. Its correct answer is option C. Means the volume of the gas is due to the large number of molecules present in it. This is the wrong. This is not given. Okay. Here you have to tell the correct postulates. Which one of the following is not a correct? Not only because the other three are correct. Not a correct. Then except these, all are correct. Not a correct, you have to select. Then all three are correct. A is correct, B is correct, D is correct. Means the molecules of gas are continuously moving in different direction with different velocities. That is correct. Second, the average kinetic energy of the gas molecule is direct proportional to the absolute temperature of the gas. This is also correct. And D, the pressure of the gas is due to the heating of the molecules on the wall of container. This is also correct. C is not correct. Option C. The volume of the gas is due to the large number of molecules present in it. It is not coming under the postulates of kinetic theory of gases. Hence, answer is C. Correct? This is not the postulates. This is a direct, you can say, answer. Direct question answer. The volume of a gas is due to the large empty space between the molecules. About the volume, this is the correct. The volume of the gas is due to the large empty space between the molecules, not only due to the molecules. Because molecules are not touching to each other, they are just separate. Hence, total volume, the volume of the gas is due to the large empty space between the molecules. But here it was given the volume of the gas is due to the large number of molecules present in it. That is not correct. Then today I am stopping only here. Next class again I will continue. Thank you.